Let's do our second. So now we're getting into examples. So I think we'll do two algebra to trigs, and the next one we'll do two trigs to algebra. Here we go. That's all the important information that you would need. So let's take this and make z is equal to, let's call it 4 minus 4 I. And we're going to want to convert this. We want to make it look like trig, put in that trigonometric form. Which means we're going to need to solve for some stuff. We're going to need to do a little of this, a little bit of this, a little bit of this. I don't know. You know what I mean? Now we're going to have numbers. We're going to have to find the angle. So really, we already know A and B. We're looking to find what's theta and what's R. Right? What's theta and what's R? Okay. So let's use some logic here. Well, let's go get R, huh? I think R is probably the simplest thing to get. Just start right off the bat and let's run through it. Like, okay, well, let's go get R. So R is going to equal the square root of our component squared. So positive 4 squared plus negative 4 squared. R is equal to, what's that? 32 or two of those 16s. So R is equal to the square root of 2 times the square root of 16. So R is equal to 4 times root 2. Okay. That's not stuff you're used to. But now we got to go get that angle. Now we got to have to go get that angle. And there's something I haven't done. I haven't done it yet. And that's just to make a quick sketch. Because we don't know what quadrant this is in. So let me show you what I mean. You know, tangent of theta is equal to b over a. Cool. So our b in this case is what? Negative 4. And our a is positive 4. So I'm going to say negative 4. There's our b over our a. So tangent of theta is equal to negative 1. Now what's the angle? You know, I mean, we can hit this thing with an inverse. Are we sure we're in the right quadrant? Because this is going to pop out and this is going to tell you negative 45 degrees or negative pi over 4. I'll write that as negative pi over 4. Or you can think negative 45 degrees. Are you sure that's where we're at? This is what I mean by a sketch. Look, the a value is positive. The b value is negative. So we're down here somewhere, all right? Let's draw something like this. Now, does that make sense that this would be negative pi over 4? Would that be the right quadrant? Yeah, it will. But there's going to be times when that is not the case, depending upon what quadrant we're in. So we want to make sure to at least give yourself a little sketch so you don't do something silly and you make a mistake, because as a jerk teacher, I'm always trying to set you up. Now, a lot of the times, we don't want to have a negative in our answer. Now, I'm just going to write it out, which, I mean, I would be fine on an exam if you did this and say that z is equal to, we're going to follow this form. Just following that form that's right up there. Get rid of some of this nonsense. And we're putting in r is going to be on the outside of our parenthesis. We're like, okay, so r was 4 root 2. Oh, sorry. And we can say times cosine of negative pi over 4 plus I sine of negative pi over 4. A lot of times it's asked for you to keep it all positive though. So what we could write in would be what it's coterminal to. So down here, instead of calling it negative pi over 4, we could also just call this positive 7 pi over 4. And we could write it in as such. So depending upon how the question is asked, your teacher doesn't care if you leave it like this. However, your text might want it, or your online homework might want it all with positive angles in between 0 and 2 pi. And that's how the game is. You just have to go solve and place things where they go. The radius on the outside, the angle sitting here, they're always the same angle. It always goes cosine plus I sine. There it is. So let's do another. Let's mix it up a little bit. And let's say z is equal to, and let's go with negative 2 minus 2 root 3. And let's take this and let's turn this in to trig. So we're going to want to find our radius first. So let's go get the radius. We'll be like, all right, so the radius is equal to the square root of the components squared and added together. So negative 2 and negative 2 root 3. So that's 4 plus 4 times 3, that's 12. That's 16. So r is just equal to 4. Oh, well, we're almost there. Oh, yeah, so let me just write it out. C is equal to 4 times cosine of. We're going to go find that angle plus I sine of. We're going to go find that angle. So the only thing we're left having to find now is our theta. We just have to find our theta. Okay. Theta is equal to inverse, oops. I'm sorry, I'm going to write it the way your book has it. Tangent of theta is equal to our b, negative 2 over root 3, over a, negative 2. So what's that? Just positive root 3. Tangent of theta is equal to positive root 3. And now if you hit this thing with an inverse, you would find out that theta was equal to, oops, why did I write a plus sign there? Wouldn't that be equal to pi over 3? And I'm pretty sure if we go and we graph this, you know, just a quick sketch, negative 2, negative root 3, negative 2 root 3, aren't we down here a negative x, a negative y, oops, I mean a negative real and a negative imaginary for something down here? I don't think this equaling pi over 3 would make a heck of a lot of sense. I don't think that's going to be the right spot. That might be the reference angle. But what we're going to find, if you are in quadrant 3 or quad 2 or quad 3, you must add pi to your angle. Because look, we go over here with our tangent, or our theta is equal to the inverse tangent of root 3, and we get pi over 3. But if we would have recognized we're over here in quadrant 3, all we need to know is like, oh, no, this was not theta. We weren't finding theta, we were finding our reference angle. So our actual angle is going to be pi over 3 plus pi, which is going to give us 4 pi over 3. And that makes a hell of a lot more sense. So as long as you get your pi over 3 out of it, or your negative pi over 3, or whatever, you just look and you're like, dude, I just need that frickin' reference angle in that quadrant. And that's why your text writes it as tangent of. So you have to actually look at it and figure out what quadrant you're in. So now that we found our 4 pi over 3, we're just going to place that right on in there. And there is our solution. Fun stuff. Fun stuff. Little subtleties, but it's all the same little subtleties you've already been going for. We're just doing a little bit of a new game. So we're finding our r's and our thetas. We're plugging them on in. And next we're going to go the other direction. And actually the other direction is quite a bit easier. I think I said it backwards in the first video. But the other direction is, it's piece of cake. It's no big deal at all. We'll run through it. So, all right. I'll see you in the next.